Guys, I'm your math teacher Tao. In this new series of videos, I'm going to share with you some of the most easily ignored math concepts in DSAT. And today we start from remainder theorem. I'm going to explain what the concept is and then follow by an example to help you better understand that. Okay, let's get started. So first of all, what is a remainder theorem? Simply put, it means, for example, if I have a polynomial p of x, and if I want to find out what is the remainder when this polynomial is divided by a linear expression such as x minus a, what I need to do is first let x minus a equal 0, so I get x equals a, and then plug in x equals a into p of x into the polynomial. Whatever that value of this expression is, that is the remainder. Let me use an example to illustrate this. For example, if I have a p of x equals this, and if I want to find out what is the remainder for p of x divided by x minus 1, based on the remainder theorem, what I'm going to do is first let this linear expression equals 1, so I get x equals 1. Let this expression equal 0, so I get x equals 1, and then plug in x equals 1 into the polynomial. So the remainder will be p of 1. Okay, input x equals 1 into the function, I get 2 times 1 squared minus 5 times 1 plus 4. And this is 1. So I can say the remainder is 1. Some of you might wonder, is this really true? I guess most of you know long division, right? So we can use long division to test this. For example, 2x squared minus 5x plus 4 is divided by x minus 1. First of all, we multiply x minus 1 by 2x. So we get 2x squared minus 2x. And we subtract the result from the first expression. So we can cancel out 2x squared, and negative 5x minus negative 2x would be negative 3x, then plus 4, and then multiply x minus 1 by another negative 3 in order to cancel out negative 3x. Then subtract, so 4 minus 3 is 1, which is indeed the remainder that we just got, right? Actually, we can use the long division to explain why we have this remainder theorem. For example, if I have a p of x divided by a linear expression x minus a, by using long division, I will get an integral part and also a remainder part. And now, if we multiply both sides of the equation by the denominator x minus a, we can rewrite this equation into p of x equals x minus a times q of x, then plus r, which is the remainder. And then something, if we you notice that if we input x equals a into this equation, we will get p of a equals a minus a times q of a plus the remainder. And here a minus a is 0, and 0 times anything is also 0, right? So actually we can cancel this part. So this equation is reduced to p of a is equal to the remainder, which is exactly the remainder theorem. Okay, so this is why we have this remainder theorem. And next, let's apply this into a question. For this question, it says, for polynomial p of x, we know p of 3 is negative 2, and we need to decide which statement must be true. For choices A, B, and C, they're very similar. We need to decide whether an expression is a factor of p of x. So if you're very familiar with factor and x-intercept, if you're familiar with their relationship, you're able to cancel out the three choices, like rule out the three choices. For example, if x minus 5 is a factor, then we can say that x equals 5 should be a 0 or an x-intercept for p of x, right? Which means p of 5 should be equal to 0. But it's not given in the question. It only tells us that p of 3 is negative 2. So it's not a must-be-true statement. And it's the same situation for choice B and C. But here we're going to focus on using remainder theorem to test choice D. Choice D says the remainder when p of x is divided by x minus 3 is negative 2. Okay, so let's write this statement in this way. P of x divided by x minus 3, we're going to find the remainder. Just now we talked about remainder theorem, so we can apply it here. The remainder will simply be when this expression is equal to 0, we get x equals 3, then plug in x equals 3 into p of x. So that means the remainder would be p of 3, right? And the question tells us that p of 3 is negative 2. So it means that the remainder would be negative 2 if p of x is divided by x minus 3. That means choice D is correct. Okay, so that's how we can apply the remainder theorem to questions. So that's all for today. Hope this can help you with your preparation for SAT. See you next time. Bye bye.